Hello to everyone. I want us today to look at physical sciences, grade 12. Okay, so we are looking at projectile motion today. Alright, so we have a question there which says a ball is thrown vertically upwards from the top of the building. This is our ball thrown vertical upwards from the edge or from the top of the building. The building is 18 meters above the ground with a speed of 2,1 meters per second. The ball is being projected upwards, or it's being thrown upwards at a speed of 2,1 meters per second. We have to ignore the effects of friction or the effect of air resistance. Okay, this is our building. Okay, 18 meters high building. This is the ground, the object that is being thrown upwards there at 2,1 meters per second. Okay, I hope you understand everything in our statement. Hope you understand everything. The very first question here, number one, explain what is meant by projectile. We have to define the word projectile. What is meant by projectile? Everyone knows, guys. So when you talk about projectile, so you can just simply say that, okay, so projectile. So you know that the projectile is an object that the only force acting on it is gravitational force. So if I throw this object upwards, you can see that it comes back. Why it comes back? Because there is a gravitational force that acts on the on this particular object. So projectile is an object. So is an object. So projectile is an object whereby the only force acting on it is gravitational force. Okay, yeah, gravitational force. And remember that this particular object has initial velocity in this case. So in this context, this object has initial velocity. So that's a projectile. Projectile is an object whereby the only force acting on it is gravitational force, and that particular object has initial velocity. Hope you everyone understand. Okay, let's move to number two. So number two says, write down the magnitude and direction of the acceleration when the ball reaches its maximum height. You know that at some point the ball is going to turn back, but before turning back, its velocity must be zero, because as it goes upwards, it decreases in velocity. So until it reaches zero, which is maximum height. All right. So we have to write down the magnitude and direction of the acceleration when the ball reaches its maximum height. All right. So the acceleration of the ball or of the object while on the motion in air, you know that it's gravitational force, right? Yes, which is 9,8 meters per second. All right. When it's there at maximum height, it's still gravitational force pushing it downward. That's why at maximum height it stops and come back. Okay, yes. Okay, yeah. All right, so here the answer is 9,8. That was number one. So for number two, let's just write number two here. So for number two, that's going to be 9,8 meters per second squared. Downwards. Okay, downwards. That's how it goes. Okay, yeah, that's it. So that's it. I took this question paper. I took this from a specific question paper, by the way. Just forgot there. All right, but I think it was around September. Okay, but it's a good practice, guys. Let's move. So number three, calculate the speed at which the ball strikes the ground. The speed at which the ball strikes the ground. Okay, going to use this one in this instant, okay? So we're going to use this one here. All right, we have to calculate the speed at which the ball strikes the ground. All right, the ball is being projected upwards, comes back to strike the ground, okay? So we have to calculate the speed, meaning that the final velocity there. All right, so at number 3, by calculating the final velocity there, do we have the initial velocity? Yes. Do we have the acceleration? Yes, 9.8 meters per second downwards. Do we have the change in y? Yes. Do we have change in time? No. Something that we have to look for. So VF we're looking for, we don't know. So VI, yes, we have acceleration, yes, we have change in y, yes, we have change in time, no, we don't have it. So that we have to look for the equation of motion that consists of all of these variables here. Okay, so which one is going to suit? It's VF squared. VF squared is equals to VI squared plus 2A change in y. This is the one. Hope everyone can see. Okay, yes. Okay, let's calculate now the final velocity, or the speed of the ball, which strikes the ground. So we're looking for final velocity squared is equals to, the initial velocity is 2,1 squared. Okay, in this case, let's choose upwards as positive in each and every instance to arrive on this question, okay? Yes. All right. So plus 2, negative 9,8, change in y is negative 18, because starting from the top downwards, calculate the distance of the building, negative 18. So our VF squared is equals to 2,1 squared plus 2 negative 9,8 negative 18 squared. Punch that in our calculators. All right. Okay. Give me a few seconds to see if I didn't make a mistake there. 18 not squared. That's the answer. Okay, let's just put it here. Let's say 2,1 squared plus 2 open bracket negative 9,8 negative 18. All right, so that's 357.21. So that's going to be 357.21. All right, looking for the final velocity. So VF square cancel square, so square root there. So put the square root there of 357.21. I hate calling numbers this way, by the way. So 18. So sorry. The square is not another. 18,9 meters per second. The second, okay. So that's the final velocity whereby the ball will strike the ground. When the ball comes back to strike the ground, it will strike the ground at 18,9 meters per second. Let's move to number 4. All right. So number 4 says, calculate the height above the ground reached by the ball 1,6 seconds after it is thrown vertically upwards. We have to calculate the height above the ground reached by the ball, by this ball, by that object there, 1,6 means that after 1,6 it is thrown vertically upwards. In this case, we know the time, okay? We know the time, okay? We're looking for this one. The VI is there, VF is not there, so that is X is not there. Acceleration is actually there, so acceleration is actually there, so we're taking out the VF in this case, which is final velocity. So which one are going to use? So this one, which is change in Y, so change in Y is equals to VI change in time, right? VI change in time plus half acceleration change in time squared. Hope everyone understand that one. So we're actually looking for change in Y in that case, right? Yes, because we have to calculate the height above the ground reached by the ball, or after 1,6, it is thrown vertical upwards. Okay, so that's going to be 2,1 change in time, which is 1,6. We are still choosing upwards as positive. 1,6 seconds plus half negative 9,8 1,6 squared. Okay, so this is going to be equals to, punch that on a calculator, so that's going to be 2,1 1,6 plus half negative 9,8 1,6 squared. Okay, so we have negative 9,184. Because we haven't yet arrived to the answer, let's wait for rounding off to 2 decimal places, okay? Because we haven't yet arrived in the answer. All right, so remember now, if for those maybe who don't understand the question, I hope everyone can see, by the way. Yeah, everyone can see. It says we have to calculate the height above the ground reached by the ball 1,6 seconds after it is thrown vertically upwards. So in this case, we have to add the distance of the building, which is 18 meters high, from this height, okay, reached by the ball after 1,6 seconds. Let's do that right now. So our change in Y in this case will be equals to 18 meters, okay, yes, plus this, okay, which is negative 9,184 meters, okay. So our change in Y, therefore our change in Y will be equals to, let's just simply say that because it's going to be negative, okay, so it's going to be 80 meters minus 9,184 meters. So let's just put plus 18 there. So that's the final answer, and therefore our change in Y, will be equals to 8,816. Let's just round it off to 2 decimal places, okay? 2, okay, meters. All right, that's how it goes. Right? Yeah. Okay. That's the final answer. Highly correct. Okay. Yeah. Forgot to mark. So that's going to be how many marks? 4 marks. 4 marks. So how do we mark that one? All right. So for the use of the correct formula for a substitution there, also here, so we have 4 marks. How many marks? Number 3. So that was 3 marks. Okay, yes, that was 3 marks. Highly correct. Everything was correct, as well as 2 previous questions, which were similar. Okay, so let's move to, I hope everyone understood this one, number 4. Okay, I want us to move to number 5. Okay, number 5, which is 5.1. Number 5 then, which is 5.1. Okay, Let's just move a little bit like this so that everyone can see. Okay, I hope everyone can see. Just give me a little bit so that I can check. Okay, everything is fine. All right, so number 5. So we have 5.1. So number 5 says, on reaching the ground, please listen carefully on this one. On reaching the ground, the ball bounces elastically from the ground with the negligible contact time. Okay, so the ball bounces. Remember that the ball was thrown upwards. Okay, the ball was thrown upwards until the maximum height, and then goes down. And here we know the final velocity. What was the final velocity? I mean that the ball bounces again. Okay, upwards again. Okay, yes. All right. On reaching the ground, the ball bounces elastically. Okay, let's talk about this word here. Elastically. Okay, this promotes, or this reveals that an elastic collision occurred there, meaning that there was no energy lost before the collision, meaning that before the ball hits the ground, there was no energy lost. So meaning that after the ball bounces, the velocity of the ball will be equal to the velocity when the ball hits the ground. Okay, yes, that's how it goes. Something that nothing that's going to change here. I mean that the energy before is equal to the energy after the collision. That's what it basically means. All right, so from the ground with negligible contact time. Negligible contact time means that the contact time between the ball as well as the ground when it was bouncing off the ground, it was quite very short, to the extent whereby you can't even include it into our calculations. We can't even consider it. I mean that it was maybe 0,00001. That's still 0. Okay, yeah, that's how it goes. Okay, so we have to sketch the velocity time graph. Okay, hope everyone can see. Sketch the velocity time graph for the complete motion of the ball until it reaches its maximum height after rebouncing. We have to sketch the velocity time graph here. Okay, yeah. So we have to show the following on the graph: the velocity of the ball when it is thrown upwards. The velocity of the ball is thrown upwards, which is this one. Okay, we have to show this 2,1 meters per second, as well as the velocity of the ball when reaching the ground, which was 18,9 meters per second. That's how it goes. Okay. All right, so let's sketch that graph right now. Okay, it's just look like this. Please forgive me, I'm not going to be on scale. I'm just going to use and I'm just not going to be on scale. Please forgive me, guys. Yeah. Okay, so we have velocity on y-axis in meters per second, and we have time in seconds there. Okay, so let's focus on what is given there. That must be the velocity of the ball when it is thrown upwards. It was 2,1 meters per second. At least it was around, let's say, at this point here. Okay, let's say 2,1 meters per second, and the ball goes up until it reaches maximum height, so that the velocity decreases until it becomes 0 to the maximum height. After the maximum height, the ball continues to be in motion, but now downwards. Okay, to be in motion but downwards until it reaches the ground at 18,9 meters per second. At 18,9 meters per second. Okay, so let's just say maybe this is going to be 18,9 meters per second, and remember it is negative, okay, because this is the upward motion. Remember, we chose upward as positive, remember, okay? Yes. All right, velocity time graph for the upward motion as positive. Okay, so that's going to be negative 18,9 there. The final velocity when it hits the ground. Okay, so basically in this case, the velocity of the ball reaching the ground, we definitely done. But look now, it is stated there that it is stated here that on reaching the ground, the ball bounces elastically from the ground with negligible contact. We have to sketch this graph for the ball motion of the ball until it reaches the maximum height after bouncing. Maximum height after bouncing. Remember that the correlation was elastic, so that energy before is equals to energy after. All right, as well as our velocities are equal in that case, so they must be parallel. Okay, they must be parallel with the second graph. Okay, so the second, let's say that it bounces, and after that, not after 0, something seconds within the contact time, it bounces off. No, it was negligible contact time. I explained that one. Okay, so I mean that we're going to move at least till to this point, this time when it bounces. Okay, yeah. All right, so in this case, okay, so I mean that this one is going to be equals to that one, or it must be at least above 2,1 seconds. All right, let's move upwards and move downwards. Okay, said you I'm not going to go on scale, guys, so sorry, but at least they must show that they are parallel. Okay, okay, that's how it goes. So at least these two graphs are parallel, and that's how it goes. Okay, yeah. All right, so this is going to be the mark, and for being parallel. Okay, yeah, so that's going to be your 3 marks, and we chose upward as positive for this velocity time graph of this instance here. Okay, so I think you get everything, guys, but if ever you still have questions or any videos, if you'd like me to cover some contents, please say so in the comments. Have a great one. Just don't forget to subscribe. Thank you.